Hello, welcome to the next lesson in Spiral 5, interpreting graphs. So we did something like this similar in an earlier unit with respect to velocity and time, or speed and time. So now we're interpreting graphs for any given situation. So for the first example here, we have the graph of a bathtub. So in the given graph, it shows the height of water in the bathtub. Use it to answer the following questions. So the first thing you want to do when you see these types of graphs is kind of pick out what's going on in terms of the graph. So on the x-axis we have time, so how much time has passed, and on the y-axis we have the depth or the height. All right. All right, so first question here, what happened from C to D and from F to G that would cause the water level to change instantaneously? So very, very fast. So the 2 points that we're looking at, or we are focusing on, is this section right there and that section right there. So why is there an immediate or almost an immediate change in that depth? So if you think about a tub, the question you ask yourself is, what causes a quick change in depth in a tub? All right, and the answer here is a person getting in. All right, so a person getting in the tub quickly. All right, so if you just drop yourself into the tub very, very fast, what will happen is the water level will shoot right up. So will it ever be a perfectly vertical situation? Probably not, because you're not going to do it in 0 seconds. But for the purposes of this example, it would almost be instantaneous here. So if you get into the tub very, very fast, okay? What part of the graph shows the actual bath? So what they're talking about, the bath part, all right? So the actual bath. So let's talk about the soaking. So you're actually in the tub playing with rubber ducky. Oh yeah, you guys are shaking your head. You know you got your rubber duckies. All right. So what part of the graph is where you're just soaking, relaxing? Well, the section here would be the section D to E, because if this is where we get in, this is where we get out, then the soaking part will take place in between that. All right, so your soaking part will take place in between that, which means that even this section here is part of the soaking process. So to answer this question, it would be from D all the way to F. What's happening from A to B? Well, we know that this part of the graph right here, all right, is our origin, which means it's 0, 0. So at time 0, there's no water. Time passes, and we have a direct variation, all right? And it's linear, so that means it's going up at the same rate. So that means you've turned on the tap, and it is filling. So filling the tub is what's happening from A to B. When did the person pull the plug? So it's a bit of a trick question, because some people are they pull the plug after they get out. All right, some people pull the plug before they get out. So in this case, you got to figure out, when does the water level start decreasing at a steady rate? Because when it goes down the drain restricts how fast it'll exit. And in this case, we can see that the steady decrease starts at E. Then you have this quick jump where you get out, but then it continues on that steady rate. So these two parts are parallel. So you pulled the plug at point E. So at point E, all right, you pulled the plug to start draining that tub. All right, so very similar to your the speed distance time graphs that we did in unit, I think it was unit 3 or spiral 3, and we're going to talk about that. There's space provided, different lines in their meanings. So it doesn't really matter the units here. You're just giving yourself a quick sketch. So this graph, we're going to back in unit 3 there, we talked about specifics. We're doing distance time graphs. Now we're just talking about graphs in general. So in this case, what can you tell me about this graph? We have something increasing. So increasing at a steady rate. All right, so something is increasing at a steady rate, which means the partner to this would be a graph that looks like this. So when we've done lines of best fit, we talked about positive relationships and negative relationships. Okay, positive relationships occur when the y value is increasing. Here the y value is decreasing. It's a negative relationship. So we are decreasing at a steady rate. All right, so it doesn't matter what we're talking about, speed, volume in the tub, etc., etc. Something is decreasing at that steady rate. Next, when we have a horizontal line, there is no change, so we're not getting greater, we're not getting less. So we have a constant value or no change. So the volume in the tub did not change when it was horizontal because it wasn't increasing, it wasn't decreasing. All right. Then you'll run into some other situations we talked about way back in Unit 3. All right. I'm not too worried in terms of this course, in the applied course, because we don't really deal with these particular curves. So I'll just go through this kind of quickly. And it's more the space, just find a little bit of space. You can shrink these graphs together. So we have a graph that looks like that. We have a graph that looks like that. Graph that looks like that. And a graph that looks like that. All right. So these are all nonlinear, which means not a steady rate. All right. Not a steady rate. Okay. So again, if you think back to our terminology, okay, the y value here is increasing. So this is increasing. All right. And you kind of look at, is it getting steeper or less steep? So if it keeps getting steeper and steeper, because remember we said on a graph, your rate of change or your unit rate, the steeper it is, the higher it is. So this is increasing, and we'll just go faster. All right. This one, the y value is increasing, but because it's flattening out, it's starting to look like our horizontal line above here. All right. It's starting to look like this. So we say slowing. Here, the y value, it's decreasing. And again, it's flattening out just like this one up here. So we say slowing. Oops. All right, and then this one, it's getting steeper and steeper. So the y values are decreasing. And again, oops, it's decreasing faster and faster. I haven't seen, maybe you see one question like this in multiple choice, but for the most part, you're going to be dealing with these three up top that I've drawn. These four, I've maybe seen it once in a multiple choice question. You know, which one shows something that's increasing faster and faster? And they give you these four graphs, so you just got to pick it out. So you just got to talk your way through it. All right. Finishing off the note then, bicycle trip. So we're back to a distance time graph. I see these in EQA all the time, so that's why we spend a bit of time focusing on it. So Mary and Carol set out for a bike trip. The distance time graph shows their progress as they reach their destination. So details you should include. What are we doing here? Oh, write a story that describes their trip. This could be a play-by-play sportscast. All right, so I've seen this before, question exactly like this in EQAO. Let me give you a bit of a checklist up here. What I would do is I would just kind of describe, go region by region. So for me, this would be region 1. Okay, so let's describe region 1. So Mary starts biking, and describe how. So it's a straight line. So she starts biking at a steady rate. What happens with Carolyn? What does she do? Carolyn starts biking at a faster rate. Now, why is it faster? Again, don't put your hands up. It's a video. I can't see you. Come on. If you look at the steepness, look at your steepness. So here's Mary, Carolyn, much steeper, faster. Steeper means faster. At a faster rate. But the difference is she didn't start at the same time. So she starts 1 hour later. Okay? Now, you probably have a little bit more space, so I'm going to keep shrinking this down, but a little easier probably for you. You just keep moving down. So now let's look at stage 2. Okay? So what happens in stage 2, and we can describe both of them in this case. So in stage 2, they both, now it's a horizontal line, so that means there's no change. Okay, you're asking no change in what? It's whatever's on the y-axis. There's no change in distance. So both bikers stop. And if we take a peek here, 1, 2, 3, 4. So 1, 2, 3, 2, 3, 4. They stop for different lengths of time, but both bikers stop, we'll say, for a break. All right, what happens for stage 3? So stage 3, again, I'm gonna say the same as stage 1. All right, so both Mary starts at a steady rate, Carolyn starts biking faster, but Carolyn waits. How much longer was that? I gotta erase this just to take a peek. So the distance here is 2 jumps, and there's 1, 2, 3, 4 jumps. So they've broken in 15 minutes. Waits 30 minutes after Mary. Can you kind of see how your story comes out of this? Final stage, again, they both stop. So stage 4, both stop for 15 minutes. And then they take off again, but this time Mary is going faster. All right. So it gives you a flavor. They're not going to put this many stages in. This is why I'm kind of stopping at this point. They're probably going to put 3 stages in, most, maybe 4. But it gives you an idea of what's expected. So you want to talk about steady rate, time delay, coming to a stop, etc., etc. So that should give you a feel for what's expected and be able to do the associated homework. So if you have any questions, this is time to stop the video and make sure you ask the teacher to clarify for some stuff. But hopefully that kind of makes sense. It is an extension. We've done something similar to this in a previous unit. So if you're sitting there saying, haven't we done this before? The answer is kind of. We have. This is just taking it one step further. All right, good luck, and we'll see you in the next video.